Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 2, or question number 1 actually, from the Solomon F collection of mechanics papers from the Edexcel board, which corresponds to question number 2 from my end of topic worksheet for my Edexcel M1 course on statics. This is worksheet number 7. This question here is about a particle of mass 4 kilograms resting on a smooth plane inclined at 15 degrees to the horizontal. It's held in equilibrium by a horizontal force F. So there's no friction involved. There's a force holding it in place. Okay, it's in equilibrium on this inclined plane. We've got to show that the normal reaction exerted by the plane on P is 40.6 newtons, correct to 3 significant figures. All right, so I have a little kind of copy of this diagram here to help us. Now, in this question, what I would normally do is I would normally resolve the forces perpendicular and parallel to the plane. That's how I would normally go about such a question. But I can see there's a slight difference in the way that they've asked us to find the answers, because they want us to first find the normal reaction force and then after that find what F is. Now the way I would go about doing this is my method would involve finding what F is first, okay, and then finding what R is. Okay, so I'm gonna do it in the way that the order that they asked us to do it. So first thing I'm gonna do, I always like to do this, is any forces are acting like pushing something, I like to draw them on the other side. It doesn't make any difference to the calculations. It just makes things like resolving forces, for me anyway, a bit easier. So you don't have to do this, but I like to do this. So I'm going to just redraw that F on the other side. That's the same thing exactly. Doesn't make any difference to the calculations whatsoever. And I'm just going to extend this line a bit so that I have a bit more space there. Okay, so that makes me able to resolve forces a bit easier. Now what I'm going to do here, because we want to find what F is first, let's first put all the forces that are acting on this. You have the weight acting vertically downwards. That's not vertical. Okay, vertically downwards. And you have the reaction force, which is perpendicular to the plane. And that's what we have to show is equal to 40.6 newtons. So I'll call that R for now. Oops, I'll put it on my... That's R. And that's the weight, which is 4 times G newtons. Okay. Now, I'm going to draw this line over here. All right. I know that this angle here is the same as this angle here. Okay, now a lot of students don't understand this, so I'm going to go into a bit of detail to explain it for those who don't. Why is that angle 15? A lot of people just basically memorize that angle and that angle are the same. They don't understand why. I'll just show you why for those of you who like to know why. Now, I know that this 15 degrees is part of this big triangle, which is a right angle triangle, because this is the reaction force perpendicular to the surface. So that's perpendicular to that. And I know that this small triangle here also is a right angle triangle, because this is the vertical weight, line of weight, and this is the horizontal. So that's right angle as well. Right, now I know that these two, this big triangle and this small triangle, they both share an angle over here. This angle is common to both of them. This angle is the same in this small triangle as it is in the big triangle. So this big triangle and this small triangle, they both have two angles which are exactly the same. They both have a right angle and this angle. They both have a right angle and this angle. Okay, so they are similar triangles. Okay, they're similar triangles. That means the third angle must also be the same. So if that's 15, that must also be 15. So it's from similarity we know that angle's 15. Okay, anyway. Next, we want to find that the normal reaction force is 40.6. So as I said, what I normally do is I would normally, and we know this angle is 15 by the way as well, is I would normally resolve my forces perpendicular and parallel to the plane. But in that case, I'm going to have to resolve F parallel to the plane and also perpendicular to the plane, and the weight parallel to the plane and perpendicular to the plane, in which case I'll have equations with F and R in it. So I'd have to find what F is first, and then only then will I be able to find what R is. So what I'm going to do now to make it to make us not have to really know what F is, I'm going to resolve forces vertically to help us find what R is. If I resolve these forces vertically, then what I can do here is I can extend this line up. I know that this angle is 15 degrees because they're vertically opposite. So vertically, I don't have to consider this force here at all because it's acting, perpendicular to the vertical, it's horizontal. So I can just say that R times going into the angle cosine 15 is equal to 4g newtons. So I can find R immediately. R is 4 times 9.8 over the cosine of 15 degrees. And that should give us our answer. So we'll just put that in the calculator. 4 times 9.8. Whoops. 9.8 divided by the cosine of 15. Make sure that we're in degree mode. Yes, we are. And that gives us the answer exactly what they want us to show. 40.5828. I'll just write that first. 40.5828. So we got to show that it rounds to 40.6. So that's 40.6 newtons to 3 SF, as they ask us to show. So that's the way of finding R directly without having to find what F is first. Okay. Now we want to find what F is. We could go with the same flow here now. We can resolve the forces horizontally if we want to. Okay. If we resolve the forces horizontally, then I can think of the reaction force acting in this direction here. But then I've got to also think about the weight as well. So what I'm going to do for part B, I'm going to actually resolve the forces parallel to the plane. Okay, that will make life easier for me in that case because we've got this weight and other things to do with. So I'm going to do that. That's what I would normally have done actually for the other question. But because they asked us to find R directly without F, that's why I just resolve them, in a direction perpendicular to F, so we don't have to worry about F. Right? You kind of eliminate F from the equation if you resolve in a direction perpendicular to that. Well, what I'm going to do now is I'm going to resolve the forces parallel to the plane. So I've got this force, the weight acting this way, and the weight acting this way. And you have the reaction, which we don't have to worry about now because it's perpendicular to that. But we got the force F in this direction and also in this direction. Okay, so if we resolve this force in this direction, okay, that's going to be going into the angle. So that'll be F times cosine 15. Oh, that's another thing I wanted to explain even for this. That when you're resolving a force in a particular direction, if you're going into the angle, you use cosine because it's like you are trying to resolve it in the direction where, if you think about this as a right angle triangle here, that this is like the adjacent side. See what the adjacent side is. And if you're trying to resolve in the direction where you're going away from the angle, which is perpendicular to the plane here, then it's like you're trying to find the component of this force in this direction, which is like the opposite side. So we use sine. So you're going away from the angle, you use sine. You're going into the angle, you use cosine. So the same thing with the weight. 4g going into the angle, in this case it will be cosine. 4g cosine of 15. And here it will be going away from the angle, so that's 4g times the sine of 15. So if I now resolve the forces parallel to the plane, I've got they're in equilibrium because the upward forces and the downward forces balance out. So I have F times cosine 15 is equal to, and you have here 4g times sine 15. There's no other forces acting, okay, on this. The reaction force is perpendicular to the plane, so that doesn't get involved there. So you just have these two components here. There's no friction. It's a smooth plane, and it's in equilibrium, so the upward forces and downward forces on the plane are equal to each other. So I can say F is equal to 4g times sine 15 divided by cosine 15, which, by the way, is the same as saying 4g times tan 15. It's the same thing, because the sine of an angle divided by the cosine of the angle is exactly the tan of that same angle. All right, that's from identities in P2. So I'll show you how they give you the same thing. You have 4 times 9.8. I'll start off by putting sine 15 and then over cosine 15. So that gives us 10.503. Okay, and if I was to rewrite this as 4 times 9.8 times tan 15, we'll see we get exactly the same answer, 10.503. So you end up with 10.503. So to 3SF, that's 10.5 newtons. So that's the value of F. So we found the value of F and the value of R, of the reaction force, and that's the answer to question number 1 from the Solomon F paper, question 2 from my end of topic worksheet of statics. Now, if you were to have answered this question by resolving parallel and perpendicular to the plane from the beginning, you would have found F first, and then you would have found what R is. And both of those ways would be acceptable, but I've just gone by the order of this. So I eliminated the F, okay, from the equation by resolving, vertically, basically. Resolve the forces vertically. That eliminates the F because it's perpendicular to that. Right, so that's how I did that. But if you had done perpendicular and parallel, you would have had to find F first in order for you to have found what R is. Because when you're resolving perpendicular to the plane, you'd have R, and then you'd have had 4G cosine 15 plus F sine 15. And you would have to know what F is to find what R is. But doing it this way is perfectly fine. All right, so that concludes this question. Other questions from this particular Solomon F paper can be found in the playlist that will appear over here. Other questions from the topic or from this worksheet, statics from end of topic worksheet from my Edexcel collection will be over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.